Hey, today we're going to talk about heat of reaction, but before we do that, I want you to get out your reference table, and specifically you're going to open it up to table I. Now, we did talk about exo and endothermic during lesson 5.13, but today we're going to take it a little bit further, and I told you guys that before. So before we do, we're going to look at what this looks like when it is a graph. So we have what is called delta H. Delta is the triangle. If delta H is positive, it's endothermic because heat is going in. If delta H is negative, it's exothermic because heat is coming out. One other piece of valuable information is the kilojoules will be on the left side for an endothermic reaction, and the kilojoules will be on the right side for an exothermic reaction. That's all you really need to know as far as the words are concerned. Now, let's look at a graph. So this is going to be the potential energy, and this is the reaction, the time of the reaction. So as the reaction progresses, we're going to look at the energy level of both an endothermic and an exothermic reaction. So this is an example of what the reaction coordinates would look like for an endo or exothermic reaction. Before we do this, there's a lot of information here that I want you guys to know. We have this space right here. This is the amount of energy that it takes to start a reaction, which is why we call it the activation energy. It is the difference from the starting point to the peak of the reaction. Think about this. Imagine a little guy right here rolling, or a girl, rolling a ball over a hill. The amount of space to roll the ball until it goes on its own is the activation energy. Now, this activation energy is relatively low. So we have the delta H of the reactants and the delta H of the products. If you look at this, the difference between the reactants and the products is the overall delta H. If you look here, let's just assign this a random number. This is 1, let's say this is 3. We started at 3, we ended at 1. Is that positive or negative? So we ended with 1. 1 minus 3 equals negative 2. If the answer is negative, this is an exothermic reaction. So these are the reaction coordinates of an endothermic reaction. If you look here, the activation energy is actually much higher. Again, the activation energy is just again imagine a person rolling a ball until it rolls on its own. Now with the activation energy, let's just say that the products, the reactants, let's just say this is a 3 and this is a 1. So we're going to take the products minus the reactants, or 3 minus 1 equals positive 2. Since it is positive, this is endothermic. This is all you need to know, but pay attention because you're going to do your practice problems.